Determining the correct fuse size for a transformer's primary side is crucial for protecting it from overcurrent conditions. The general rule of thumb is to select a fuse rated at approximately 125% of the transformer's rated primary current. This value needs verification by a qualified electrical engineer, especially when considering the transformer impedance, short circuit current rating, and any specific application requirements. Let's walk through two examples, demonstrating how to calculate the appropriate fuse sizes. We will look at a 4000 kV transformer and a 2000/2600 kV transformer. For the first transformer rated at 4000 kV with a primary voltage of 13.8 kV and a secondary voltage of 4.16 kV, the calculation of the rated primary current is as follows. The formula to find the rated current is equal to the kilovolt-ampere rating divided by the primary kilovolt rating multiplied by the square root of 3, or 1.732. In this instance, it is 4000 kV divided by 13.8 kV multiplied by 1.732, which equals 223.8 amps. Now, to determine the fuse size, we take 125% of this rated current. Fuse size equals 1.25 multiplied by 223.8 amps, which equals 279.75 amps. Rounding up to the nearest standard fuse size, a 280 amp fuse would be appropriate for the primary side of this transformer. Now, let's consider the second transformer, rated at 2000/2600 kV with a primary voltage of 13.8 kV and a secondary voltage of 480/277 volts. We will use the 2000 kV rating for this calculation. Again, we start by calculating the rated primary current using the same formula, kV divided by kilovolts multiplied by 1.732. In this case, it's 2000 kV divided by 13.8 kV multiplied by 1.732, which equals 111.9 amps. Next, we determine the fuse size by taking 125% of this rated current. Fuse size equals 1.25 multiplied by 111.9 amps, which equals 139.875 amps. Rounding up to the nearest standard fuse size, a 140 amp fuse would be suitable for the primary side of this transformer. Therefore, the recommended fuse sizes are firstly a 280 amp fuse for the 4000 kV transformer and secondly a 140 amp fuse for the 2000 kV transformer. Remember, the final fuse selection should always be verified by a qualified electrical engineer. They will consider the specific characteristics of the transformer and the installation to ensure proper protection and coordination with other protective devices in the system. The key factors an engineer considers are firstly transformer impedance. The transformer's impedance limits the fault current during a short circuit. A lower impedance allows a higher fault current, requiring a fuse with a higher interrupting rating and possibly a different time current characteristic curve. Secondly, short circuit current rating. The available short circuit current at the transformer's primary terminals must be less than the interrupting rating of the selected fuse. This ensures that the fuse can safely clear a fault without failing. Thirdly, coordination with other protective devices. The fuse should coordinate with upstream and downstream protective devices, such as circuit breakers, to ensure selective tripping. This means that the fuse closest to the fault should trip first, minimizing disruption to the rest of the electrical system. Fourthly, application requirements. Specific applications may have unique requirements, such as the need for current-limiting fuses to further reduce fault currents or fuses with specific time delay characteristics to ride through temporary overloads. Choosing the correct fuse involves selecting the appropriate fuse type, such as a current-limiting fuse, a time delay fuse, or a general-purpose fuse based on the application requirement. Understanding the fuse's time current characteristic curve is essential for ensuring proper coordination and protection. The time current curve shows the time it takes for the fuse to blow at different levels of overcurrent. The engineer will also need to verify the fuse's voltage rating to ensure it is equal to or greater than the system voltage. Choosing a fuse with an adequate interrupting rating is critical for safely clearing fault currents. Installation practices also play a significant role in fuse performance. Ensure that fuses are properly installed and maintained according to manufacturer's recommendations. Regular inspection and testing of fuses are essential for identifying any potential problems. It is crucial to replace fuses with the correct type and rating to maintain protection. Always to energize the circuit before replacing fuses to prevent electrical shock. Consider using fuse blocks or holders that provide secure connections and easy replacement. Fuse coordination studies are essential for ensuring selective tripping and minimizing downtime. These studies involve analyzing the time current characteristics of all protective devices in the system. Coordination studies help identify potential miscoordination issues and ensure that the fuse closest to the fault trips first. Document and maintain coordination studies for future reference and updates. Regularly review and update coordination studies to reflect changes in the electrical system. Furthermore, fuse selection should align with relevant electrical codes and standards such as the National Electrical Code, or NEC. Adhering to these codes ensures safe and reliable electrical installations. Consult with a qualified electrical inspector or engineer to ensure compliance with local codes and regulations. Understanding these considerations ensures that the selected fuse provides adequate protection for the transformer and the electrical system. In summary, calculating transformer primary fuse sizes requires careful consideration of several factors including the transformer's kilovolt-ampere rating, primary voltage, impedance, short circuit current rating, and application requirements. By following the steps outlined and consulting with a qualified electrical engineer, you can ensure that the selected fuse provides adequate protection for the transformer and the electrical system. Always prioritize safety and adhere to relevant electrical codes and standards when working with electrical equipment. These calculations are demonstrations only.